start off with our presentation. The first lightning talk that we have today is titled Ergo, Open Source Multi-Hazard Risk Assessment Platform, which is coming out of the National Center for Supercomputing Applications. It's an open source multi-hazard assessment response and planning platform that is allowing users and developers to lead with a spatially enabled, extensible, semantically aware Java plugin based platform based on the Eclipse Rich Client platform that allows developers to extend the platform and add new functionality, data types, visualizations, analyses, and other things to enrich the platform's capabilities. This project's being led by Dr. Jong who's at NCSA, who co-leads the software and data analysis group and holds a lecturer position at the departments of urban and regional planning at the University of Illinois in Urbana-Champaign. His research interests focus on designing and developing and operating end-to-end cyber infrastructures to support various research and educational communities, which is has a rather long list of, I would say, a very diverse number of communities being supported, which is great to sort of get out and talk about here. And he's collaborating with various scientific domains in hazard management, hazard risk assessment, agriculture, food markets, environmental engineering, and other water management simulations, sensor work, and a rather long list of data products. Joining him today is Christopher Navarro, who is a senior research programmer at NCSA and also part of the Innovative Software Data Analysis Group. He has a degree in aeronautics engineering and a minor in computer science from the University of Urbana-Champaign. And he is interested mostly in developing and operating end-to-end cyber environments supporting various research and education communities. Very interested in cloud computing, science workflows, HPC, a rather long list of good endeavors here, and is currently working on Ergo and a few other projects with Dr. Jong. And so rather than take up all the time reading all of the great different projects here, I will turn it over to them to start their talk.
All right, thank you. So I guess I'll just get right into it. So today I am going to go over what Ergo is, some of what Ergo can do, and then talk about some of the recent activities around the Ergo project. So some of the questions that Ergo can help answer are things like, maybe I'm interested in the approximate damage due to a particular hazard, maybe an earthquake or tornado, and how it might affect the infrastructure of a region. Or maybe I'm interested in a specific class of structures like hospitals or schools, or maybe the network that's in that region. Can also help answer questions like, are the levels of damage and economic loss something that the community can recover from? Or maybe what is the most important structure to retrofit in that region? For example, maybe there's a particular bridge that crosses a major river, and that may be more important to the community and after a disaster than other bridges that have less significant crossings. In order to do that requires a lot of data. So we need inventories on structures, so like buildings, bridges, buried pipelines. We need to quantify the hazard. So are we looking at a scenario earthquake or tornado, or are we looking probabilistic? Maybe we're trying to do some event planning. We need to know the fragility, so we need to know how a structure responds to the different hazard types. What's the probability of it being damaged from that event? The socioeconomic data we're interested in, so getting short-term shelters that are available. There's a lot of geographic data, so we need to know soil types, liquefaction data. All this can help augment the model so that we can better understand how the earthquake is going to affect the different structures. So all this data it's geospatial, there's temporal data, there's results of simulation. In total, we have about 228 data types in Ergo, and that continues to grow as we add more inventory types, as we add more attributes to the system to model different structures. And all of this is brought together by the Ergo platform. So it's a multi-hazard risk assessment application As was mentioned, it's semantically aware. So all those data types allow Ergo to understand that this particular point in space, the attributes tell me it's a bridge, or it tells me that it's a building. And I know where in space it is. It's spatially enabled, so I have the GIS data to tell me where that bridge or building is. And the system's extensible. So those data types, it's growing because researchers can come in and add new data types. They can add new models. It's open sourced, so right now mostly researchers and engineers using it, adding new models, adding new capabilities. And so a typical product might look like this, where you have researchers on one side that are looking at how to model a particular hazard, how to understand the response of a structure to a new hazard type. Researchers may be gathering inventory attributes, the age of the structure, number of stories if it's a building, and all that kind of feeds into a damage prediction model, which then feeds into decision support so that decision makers have a quantifiable result to kind of make some decision based on some kind of planning, perhaps. This is a list of kind of just showing what the flow looks like in Ergo. There's about 50 plus analyses. So starting on the left, we start with the hazard, and that kind of goes into different analyses for doing bridge loss estimation, buildings, lifelines. That all feeds into then socioeconomic and eventually down into decision support. As I mentioned, it's an open source project. It's under the Mozilla Public License 2.0. It leverages other open source products, so namely Eclipse RCP for the extensibility that allows us that plugin based architecture to plug in new capabilities. GeoTools is the primary library for doing GIS. Visualization toolkit right now for 3D visualization, Jasper reports for generating reports, and so forth. So what are some examples of what Ergo can do? I'm going to take us through a couple of scenarios. So one example scenario, maybe there's an emergency manager that wants to plan for a specific event. Now, this 7.9 event is, since it's a pneumatic seismic zone, this event has happened in the past. It's been a while, but has a long return period. And if it were to happen again, a manager may want to plan for, now that Shelby County, Tennessee is much more populated than, I think, the 1811, 1812 earthquake when that happened. They would have to go through a series of tasks to understand what are the short-term shelter needs if that event were to hit again. So there's the data management piece where I need to gather the inventory, so housing, the transportation, I need to quantify the hazard. I need to analyze based on that, come up with a damage prediction for the buildings to understand, are the buildings occupiable after the event? If not, some of that population is going to be dislocated. And then from that, I need to determine what are my short-term shelter needs, what are the supplies I'm going to need, so food, water, beds, that kind of thing. So this is what Ergo currently looks like. So this would be the data management piece where I have overlaid the multifamily housing for Shelby County, Tennessee. I also have the freeways overlaid. And here's the analysis or the sequence of analyses I'm going to need to run in order to determine what those shelter needs are. So starting from the left, I need to specify the earthquake event. I need to specify an attenuation model that's going to model how the hazard response for that earthquake. That's going to feed into structural damage, and then from structural damage, I can get economic loss, and from economic loss, I can look at and determine what who's going to be dislocated, or approximately who's going to be dislocated and how many people. So this is a visualization of that result, what that would look like. So here we're looking for each structure, the amount of population that are dislocated. We can also drill down into the tabular view showing the results for each structure. The highlighted columns indicate what was added to the results. So these are the results that came out of the population dislocation analysis. You can also mouse over and get more information about a specific row in the table. And one of the nice things about the analysis framework we have is that all the analyses understand what what inputs they need and what outputs they produce. And so we can do what's called what's next. And so someone can come in and say, from household population and dislocation, what can I do next? And in this case, we want to look at short-term shelter needs. And so plugging that into the framework, we then get the short-term shelter needs for the region. We also have linking between the views, so you can click on a table row. Maybe there was something, an outlier or something that was surprising to you, or just kind of figuring out where is my dislocation happening, because maybe I want to plan and determine if I can improve that dislocation or that expected anticipated dislocation. From there, we can actually generate reports, so we can show them how many supplies they would need for 1, 3, and 7 day planning, because this is just short-term shelter needs. This is not long-term. Another scenario that I'm not going to walk through in its entirety, but another one that we could look at would be a decision maker maybe has a specific budget and they want to retrofit the highway bridges to prepare for that same event. So Ergo has a set of retrofit methods that are available, and we want to minimize the societal cost. And in this case, we're measuring that as total system travel time. And so we would set up the same event in Ergo, and the output would be the total system travel time and what the retrofit strategy should be in order to minimize that travel time. So I'm going to kind of close with just some of the recent activities around the project. So there are a couple of forks of Ergo. One by the Ergo CRC is by Seoul National University. They're looking at extending the capabilities to add HPC analyses. CaribViz is another fork looking at earthquake loss estimation in the Caribbean. That's being developed by the University of West Indies and Jamaica and Trinidad and Tobago. And then finally, there's another one is the Center for Risk-Based Community Resilience Planning is a NIST-funded center of excellence, and they're looking at cascading hazards and their effects on buildings and bridges. That's a $20 million project for 5 years. It's currently ongoing. And the product of that is going to be INCORE, which is going to add the cascading hazard to the platform and look at and quantify community resilience to those different hazards. So looking at tornado, tsunami, fire, earthquake, and then combined hazards as well, so earthquake and tsunami. I think that's all that I had. Should I just go ahead and turn it over?
No, it's very interesting. Thank you very much. Any sort of questions around?
Yes, can you hear me?
Yes, we can.
Great, this is Florence. Hey, that was a great presentation. Are you working with any construction and engineering management firms that may be providing services for municipalities in these areas? You know, like a Floor or a Jacobs or a CH2M or somebody like that?
This is Jong. We don't have that connection with the industry, but one of the researchers in the project INCORE has a background in the construction management and civil engineering. So we know that there's some aspect, but we don't have that direct connect to the industry yet.
Or again, this is Jim Myers. Question, comment. So I know the history here that this has been around for probably what 12, 13 years in various guises. So it's an interesting project, and that I think it's stayed alive on merits that the people doing these kind of analysis, you know, see this as better than what they've had. And so I think some of the earliest stuff actually did involve like the electric power companies in the areas that they were working with and so on. But I know it's had a tortured history. So I guess two things I would ask questions of would be one, what's it taken to keep this alive kind of beyond the end of the original grant, and how hard was that? And I guess the other one, I again would probably give this credit to being sort of part of the big data craze before big data came along, that this was the first kind of system that was pulling out like individual houses and modeling, you know, all of the infrastructure in an area. And so even though it's not supercomputing, there was really much more data intensive than the current things when it started. So I'm curious how much big data is played in here as well, for two questions.
Yes, this is Jong again. The first question, so one of the things we are able to sustain this project was NCSA helped us to provide some salary of the person time and also provide a server, some data repository server maintenance. So I think that's a major in terms of the human power-wise. Another thing is the community. After this project was originally developed by MAE Center, and that's a ERC project funded by NSF, after that, we got great interest from European countries and international communities. So that's the community make these things alive. Right now, we know that European countries, some of them, they are using it, and some universities are using it, and Italy and Lebanon, Turkey, and things like that. So I think that's another basically community help us to sustain this project. Second question is about big data aspect. That's currently we are moving on to, especially project with South Korea. Their approach of risk assessment right now, a little bit building specific. For example, in the Ergo project, most of building have a one structure type, and the structure type is called the fragility curve, represent how the building is fragile in terms of earthquake or hazard. And the South Korean approach right now, they actually divide into more detail. They developing fragility curve for each component of structural building. So like beams and connectors and floors and things like that. So they want to do that detailed risk assessment for the building, not a single building, but throughout the entire city. That's going to be a lot of computation, a lot of data. So we are currently, for that project, we are developing HPC support in Ergo. So Ergo able to submit the job and control the job status and also transfer the input and output back and forth with HPC between Ergo clients. That's currently we are working on.
Very cool.
Oh, it is very nice. I was just, going to say this is a great project. Sounds like it has great roots. And did I hear that you were actually also working with some of the NHERI folks in one of those centers?
Yeah. So yeah, go ahead.
I was just going to say, so if you could tell us a little bit about that, because we did have Ellen Rathje on last month from DesignSafe, who was talking about some of the infrastructure that's going on there. But I'd like to, it'd be interesting to hear sort of where this is going in that framework.
So I think there is no direct interaction right now, but one of the professors from Rice University who involved in the NIRI project, she is part INCORE project also. So she's kind of middleman right now, helping us to connect. So far, the interaction we had was in terms of control the vocabulary and semantics and ontologies, because we also see the value of defining ontologies on the system regarding semantically and domain. So they already started in some aspect. I know that DesignSafe and NIRI, they focus on simulation experiments, and we are more focused on community and infrastructure. So it is really a good discussion we had so far to exchange some information about what kind of ontology they are building, we are building right now. That's the kind of activity we have so far.
Very cool. No, I know being here in Austin and having, worked with folks around the whole situation with Harvey, I think, the end-to-end of all of this is what's going to be needed. So I'm glad to hear these connections are being made.
Yep.